Hey everyone, it's Miss Goobrood. Welcome to lesson 2-7, areas of complex figures. And complex figures are shapes that we need to cut into smaller shapes in order for us to solve the area of them. So take a look on page 81. Please pause this video, get your book, and open it up to page 81 because that's where we'll be working today. So work with me with the video. Pause, do the work, come back to the video, watch a little bit, pause, do the work, come back to the video. Okay, so take a look at numbers 1 and 2. They're asking us to find the area of the triangle and the area of the rectangle. Now, don't get confused here. This area of the triangle, it's referring to that triangle right there. Area of the rectangle, don't get confused. It's referring to the area of the rectangle right there. So that should be a review to you. So pause the video and do find the area of the triangle, area of the rectangle, and then come back. Okay, so if you're back, hopefully you used the formula base times height cut in half or divided by 2 or 1/2 of the base times height. Those all kind of mean the same thing, and they all get at that idea that we need to use base times height, and then we only need half of it for a triangle. So hopefully you figured that out for the triangle. Rectangle is just base times height. That's the one that we've learned kind of for a long time. You've known that probably for several years now. To find the area of the rectangle, the base times the height. You might have called it length times width. That's okay. We're calling it base times height now. So let's look at number 3. Number 3 starts us thinking about complex figure. Complex figure just means a shape that isn't a rectangle or a triangle or something that we know how to solve easily. This is the complex figure they're talking about right here. It's this shape right there. Now, you might be saying, well, Ms. Cooper, that actually is a trapezoid. You're right. It actually is a trapezoid. And we've been working on finding the area of trapezoids. But a trapezoid can also be thought of as a complex figure because look what's inside it. There's a rectangle inside it and a triangle inside it. So once you found this triangle, look at that. You found the area of that part of the complex figure. And once you found this rectangle, you found that part of the complex figure. What do we need to do to find the total area of that whole shape? We need to add them together. So the complex figure is really number 1, the answer of number 1, the area of the triangle, plus number 2, the answer of number 2, and put them together. So let's take a look at number 1. I hope you knew that was 8 square centimeters. 4 times 4 is 16, but a half of that is 8. So 8 square centimeters. Number 2, I hope you took a look at that and said, oh, yep, 6 times 4, 24 square centimeters. So to find the area of that complex figure, we need to add up number 1 and number 2. 8 plus 24. So I'm just going to write that right down in there. It's 8 plus 24. And that, of course, is 32. And because we're finding the area, it's going to stay as square centimeters. There it is. Now, that's the very, very start. We're going to do a lot of the same thing throughout this whole pages. We're just going to cut the shapes that are kind of weird, messed up, unusual shapes. We're going to cut them into chunks that we then know how to solve by finding the area of either triangles or rectangles, or maybe you could use parallelograms or trapezoids, but likely it's going to be triangles and rectangles. So let's slide down a little bit and take a look. All right, let's take a look at number 4. Now we need to find the area and perimeter. So don't forget, the area is all the space in the middle, like area alien, lands and spreads out and covers that whole area. That's the square units. And perimeter person just motors around the outside. They skateboard, they ride their horse, they walk, they run, they drive their car, however they get around, all around the outside edge. So take a look at this complex shape. We need to divide it into 2 or more simple shapes that we know how to find the answer to. So you could go right from here straight down. You could try that. You could say, no, that's not how I want to divide it. I want to divide it like this, straight across, like that. If you divide it either of those ways, you find two rectangles that you can find the area to. This rectangle now has, let me get a different color here, now has base of 5 and height of 1. So you know how to find this area. And this rectangle has base of 3 and height of 2. So now you know how to find that area. When you find those two areas, you're going to do area 1 plus area 2, and that's going to equal the area of the whole complex shape. So that's how you're going to solve all of these problems. Now, some of them might be tricky because let's take a look at the perimeter for this one. Do you notice that anything's missing? We don't have that distance, do we? It doesn't tell us. We have to figure out, how can we figure this out? We don't have it. But take a look at this. We know from the top of the shape right down to there is 2 centimeters. And we know over here from that part of the shape all the way down to the bottom is 1 centimeter. So it's 2. This is over here is 2. That's how rectangles go. That's one of the properties. And if this part of the rectangle is 1, then this part of the rectangle is 1. So we have 2 plus 1. So this distance is 3 centimeters. You will need to do that in this lesson. It will have times where it doesn't give you all the information, and you need to say, what do I know about the properties of parallelograms or rectangles or triangles that can help me figure that out? So pause and solve number 4 and then come back. Go ahead and do that. Pause and solve the perimeter and the area and then come back. All right. So now that you're back, did you get 16 centimeters and 11 centimeters? Did you find the tricky thing that was on the perimeter? I started right here. I started right at that corner and I went up here. That was my lights turned off. That was 1 centimeter. And then I turned the corner and I said, holy cow, how much is this space? How could I figure that out? Did that happen to you too? Well, maybe you then said, oh, you know what? I know I could use the same strategy that we just used on the other one. This whole length here, this whole bottom length is 5. That's 5. I know that this top length from there to there is 3. So I'm missing from here to here. How much could that be? If the whole distance from there to there is 5, and this part, that distance is 3, then that had to be 2. So this distance right there was 2. So if you got a different answer, check and see if that's the part that gave you trouble. So there's how we do lesson number 4. Let's take a look at number 5. Number 5, they already kind of, I don't know if they meant to, but they kind of cut it into pieces already for us. They already cut it into the rectangle and the triangle. So we're going to find the area of the rectangle and the triangle, and we're going to add them together. Go ahead and pause, do that, come back, check your answer. You might be saying, how do I do that? You're going to go into the answer key. It's listed in your Google Classroom under our student activity book heading in math, and you'll find the answer and check your answer. Pause and do that now. Then come back. All right, if you're back, let's take a look at number 6. For whatever reason, number 6 kind of tricks kids, but it's really just two shapes that we know how to find the area of. Look at this. You could divide it into many shapes if you wanted, but look at that shape right there. You know what that is. That's a parallelogram. And here is a reflection of it. They just flipped it over, and there's a second parallelogram. So how much work do we have to do? Not a lot, because we need to find the area of one of them, and then we can just double that. We know what the area of the next one is. So take a look at the parallelogram and see if you can figure out what is the formula for the parallelogram and how do we find one of those parallelograms. Pause and try to do that, and then come back. All right. If you're back, I hope you knew that parallelograms, how to find the formula is base times height. Because remember, a parallelogram, we could just take the triangle part on one side, take it off, flip it over, and put it over on the other side and make a rectangle. So parallelograms are just base times height. Our base is 12. It tells us that right on the problem. The height is 4. Don't get confused with that 5. We can't go to the doctor and measure ourselves leaning up and say, look how I've grown. Nope, those leaning lines are longer. We need that straight up and down to the height line. That's the actual height. So 4 times 12. So 4 times 12 is 48. So that bottom parallelogram is 48 square centimeters. Now, we could do the same thing, or we could just say, I know it's exactly the same. It's just another one. So 48 plus another 48. That's how we're going to find that. Then, how are we going to find the perimeter? Well, it tells us 12. It tells us 5. We know it's the same shape. When we're doing perimeter, should we use this 4? It goes through the middle. Don't use that 4 in the perimeter. We in the perimeter need all the outside lines, not the inside. So don't use that 4 in the perimeter. Go ahead and finish number 6 and check your answer. All right. I hope you got 5. Whoops. Here we go. I hope you got, let me grab that color. 5 plus 5 plus 12 plus 5 plus 5 plus 12 for your perimeter, 44 centimeters. And I hope you got the 48 that we already found, plus another 48 for 96 square centimeters for your area. Let's go on to number 7. Number 7 is a trapezoid. We could use any of the ways that we used earlier to find the area of the trapezoids, or you could just use it as a complex shape. You could divide it into what they already did. They already divided into the rectangle and 2 triangles. So that one might be a little bit easier for you just because that's a shape we've seen and they already divided it for us. We can see that. Let's go on to number 8. Vadim needs to know the area of this complex figure. There it is. It's a house shape. Or you could also call it maybe home plate if you're a baseball or softball player. But it's a complex shape because it's made up of more than one shape stuck together. You could also call it a pentagon. So he calls his friend Serena. Serena says she can figure out the area if Vadim will make just 3 measurements. Which 3 measurements does he need? Well, Vadim needs to know how to find the area of these 2 shapes. The area of this rectangle shape and the area of this triangle shape. What measurements does he need for the rectangle shape? He needs the measurement between F and E. He needs to know that distance. We call that a line segment, and how we write it is we write the letters F and E, and then we write a little, it almost looks like a long minus sign, just right above the top, like that. That says line segment FE. So he needs to know line segment FE because that's the base of the rectangle. Then he also needs to know the height of the rectangle. Now, the tricky thing is that these are both heights, so he could name it something else. Incidentally, he could also say AD instead. So he could say FE or he could say AD. Those are both the same. But since we already said FE, we'll also say he needs to know one of these, AF or DE. They're the same length, so it doesn't matter which one. We'll just say AF is the line segment that he needs. And again, I'm going to put that little line segment sign over the top, line segment AF. Now, there's one more he can find. Now he's got the area of the, and we'll call that the height. He's got the area of the rectangle. But, hold on. What else does he need? He knows AD already, because AD will even say, when he's doing the triangle, I'm going to put underneath here, he knows FE or AD, because those are the same, aren't they? So that's just one measurement that he needs to make, and it's the same for both. But if he's going to find the area of the triangle, what does he need? He also needs the height, doesn't he? So he has to have CB. He has to know how high it is between CB. So the other one he needs is CB. Now, you might be saying, Miss Cooper, what if I called that BC? Is it still the same distance if we start at B and we go to C? Or if we start at C and we go to B? Are those the same distance? They are. So it doesn't matter. You could write it as, we'll write an or here. You could write it as BC, and that's absolutely fine. You will find line segments written either way interchangeably. That's absolutely fine. That's a tricky problem. You probably knew which lines, but it might have been new for you how to write them or whether you had to write them in a certain order. The answer is you don't have to write them in a certain order. Oops, someone's calling me on the phone. All right. Thank you. That's sorry for that. There was someone calling me there a second ago. All right. So now I'm looking on page 82. And on page 82, again, you're going to do the same thing. You're going to cut all of the shapes into shapes that you know how to find. You might have to extrapolate. That's a fancy word for figure out. You might have to extrapolate some of the distances. For instance, just scanning this, I see, oh, we don't have a distance there. We're going to need to figure out what it is. We don't have a distance there. We've got to figure out what it is. I see this distance. We don't have a distance there. We'll have to figure it out. We might, if we cut this shape right like this, which is what I would do, we might have to find we don't have a distance here or here. So you're going to have to figure those distances out, just like we did earlier. Now, take a look at number, this is tricky. It looks like number 1, but it's actually number 11. I'm not sure why it's showing up as number 1. That's weird. But this is the area of the shaded part. Remember back a couple weeks ago when we did that one with the blueberry patch that was so tricky? This one, you're going to have to do the same thing. In order to find number 11, you're going to have to find out the area of this whole triangle, and then you're going to have to subtract this area here. You're going to have to get rid of that so that you know this, because take a look at this. We're missing the height of this triangle right here, and we don't have any reference points for it. So we won't be able to just figure out this shaded triangle. We need to find the whole pink triangle and then take away that white part, and the blue part will be left. Use those same strategies for number 12. Good luck. Remember, you can email me or chat me or come to my office hours and I can help you. See you next time.